Alright, in this one I'm going to show you how to expand using Pascal's triangle rather than the binomial theorem. Okay, and it really is the binomial theorem, it's just that's kind of where Pascal's triangle comes from. They're linked. Okay, so here is Pascal's triangle. You start with a 1 at the top and then you drop down the ones. Okay, so we have 1 and then we drop the ones down diagonally. The next row, you drop the ones down diagonally and you have a space in the middle. For that space, you add the two numbers that were next to each other. So 1 plus 1 gave us a 2 in the middle, and the ones expand here. We do the same thing. We drop our ones down diagonally, then we add the things next to each other. So 1 plus 2 gives us 3 for the next row, 1 plus 2 gives us 3 here, and a 1. Okay, and what this is doing is giving us our coefficients for expanding. Again, you drop down diagonally and then the numbers together next to each other, you add them. So 1 plus 3 gives us 4 on the next row, 3 plus 3 gives us 6, 3 plus 1 gives us 4, and then 1. Again, you expand diagonally, 1 and 1, and then things next to each other. So 1 plus 4 is 5, 4 plus 6 is 10, 6 plus 4 is 10, and 4 plus 1 is 5. We could go one more row, so I could expand my ones out here and then add. 1 plus 5 would give me 6. 5 plus 10 would give me 15. 10 plus 10 would give me 20. 10 plus 5 would give me 15, and 1 plus 5 would give me 6. That would be my next row, and it continues on forever. You can keep going as long as you want. What we use these for, if you're using Pascal's triangle to expand, is when we have a binomial raised to a power. The first line is if you have it raised to the 0 power. The second line is if it's raised to the first power. This line is if it's a squared. This next line is if it's to the third. This next line is if it's to a fourth power. This would be the fifth power. This would be the sixth power, and so on as you continue to expand that triangle. I'm going to show you what to do with these numbers. Okay, so our example here is to expand x plus 4 to the fifth power. And now what we would do is go to Pascal's triangle, find our fifth power, okay, and remember that's going to be on the sixth row actually, because we start with 0, okay. And so I'm going to take those numbers. So I have 1, and I have 5, and I have 10, and 10, and 5, and 1, okay. And then what you do is you take the numbers from your binomial. Here's our first term, here's our second term. And you start with that first term to your power. So I would start with x to the fifth, okay? And your second term would start out as a 0 power, okay? Plus, if it's positive, if it's plus here, you put plus in between all of them. So these are all going to be pluses because it was positive, okay? Then as we go to the next number in our sequence, so we started with 1, we go to 5, you're going to drop your first one by 1 power. So instead of x to the fifth, you drop it 1 to x to the fourth. And your end term, you take it up 1 each time. So it was 4 to the 0, it's now going to be 4 to the first. And we go to the next one, we're going to drop 1 again. So 4, the x would be to the third power. The 4 is going to go up 1, so it's going to be to the second power. You go to the next one, you drop your x1 again, so it would be an x squared this time, and the 4 would be up 1 from what it was before, so it's to the third. Next, we would have drop the x again, so it's just x to the first power, and our 4 would go up 1 again, so now it's up to fourth power. And finally, we drop the x again, it's to the 0 power finally, and 4 would go up 1 to the fifth power. Now notice as we started with a fifth, fourth, third, second, first, and 0 power for x's. The 4, our end term, went the opposite order. It started at 0, went up 1 each time for its power. Then all we have to do is simplify this. So, well, 4 to the 0 power is just 1. So we have 1 times x to the fifth is just x to the fifth. Okay? Plus 5 x to the fourth times 4 plus 10 x to the third. 4 times 4, or 4 squared, is 16, plus 10 x squared, 4 to the third power is 64, plus 5, x to the first power, okay, 4 to the fourth is 256. Sorry about my handwriting there. And then finally we have 1, x to the 0 power is just 1, so we no longer have an x term at the end. And 4 to the 5th power is not going to fit. It's 1024. And then all you have to do is go through and do any more multiplication that needs to be done. So we have x to the 5th plus, here we need to do 5 times 4 is 20. Here we need to do 10 times 16 is 160, x to the 3rd. Here 10 times 64 is 640, x to the 2nd, plus 256 times 5 is 1280 x, and finally plus that 1024. Okay, so that is another way to expand. It's using Pascal's triangle. Again, you find your power, you go to that row, okay, and those are your coefficients you're starting with. These are the coefficients you get using the binomial theorem also. Okay, then you take your first term, start it at your top power, drop at each one as you go along. Your end term, you start it at the 0 power and take it up each one as you go along. And we'll do 2 more of these. Okay, so let's start this the same way. This time we're going to a 4th exponent. So we go to our 4th power row in Pascal's triangle. Remember, the top row is the 0 power. So you start at the 0 power, 1st, 2nd, 3rd, 4th power would be this row right here. Okay. So our coefficients will be 1, then 4, then 6, then 4, and then 1. I just went right along the row here. Then we take our terms from our binomial. You start with the first one to your top power of 4th power. So we'll have 3x to the 4th power. The second term, you started out at the 0 power. Okay. Then we drop at 1 each time, so 3x would be to the 3rd, and your end, you go up 1. So instead of 0, it would go up to 1. Okay. Next, again, we drop the 3x to the 3rd 1, so it would be squared this time. Our negative 1, we go up 1, so it's squared. Then we have our 3x. This is the 1st power now. Our negative 1 goes up 1. It'll be at the 3rd power. And finally, we have our 3x drops to the 0 power, and our negative 1 goes up to the 4th power. Okay, so the lead one, you drop a power each time. The end, you up a power each time. Okay, let's simplify this a little. So I have 1 times, this would be 3 to the 4th. Again, there's no addition in between them, so you just distribute that exponent. So it would be 3 to the 4th power, which is 3 times itself 4 times, or 81. And then we have x to the 4th. Negative 1 to the 0 power is just 1. Plus 4 times, here we have 3 to the 3rd power is 27, x to the 3rd, and negative 1 to the 1st power is negative 1. Plus 6 times, so to give me 3 squared is 9, x squared. Negative 1 squared is positive 1, plus 4, 3x to the 1st power is just 3x. Negative 1 to the 3rd power comes out as negative 1. Alright, then we get down here. We have 1 times anything to the 0 power is just 1, and then negative 1 to the 4th power is 1. Okay, let's multiply now. 1 times 81 is just 81, x to the 4th. Here, 4 times 27 is 108. X to the 3rd, and oops, that's a negative 1 on there. So we want to actually erase here. That's one thing you want to watch for. Good thing I gave you a good example of it. Okay, Watch for those negatives. Again, if this is negative, your signs should alternate. Okay. 4 times 27 times negative 1 was a negative 108 x to the third. Okay, next we have 6 times 9 times positive 1, which is just positive 54x squared. Next we have 4 times 3 times negative 1 is a negative 12x. And on the end, 1 times 1 is just 1. Notice our signs do alternate, and that will happen anytime you have subtraction in the middle of your binomial. We had a positive, negative, positive, negative, positive. Okay? We're going to do one last example of expanding and using Pascal's triangle to do so. So this one goes up one more. We've got exponents on both of them. We have variables in both. We're going to the third power. So we go to Pascal's triangle, we find the third power. Row again, the top row is the 0 power. So this would be first power, second power. This would be the third power. So here are my coefficients I'm going to be working with. So I'm going to have 1, 3, 3, 1. We start with our first term, x squared, and we raise it to our top power of 3. The end term, 2y to the third, starts out as the 0 power. Plus 3 times our x squared, we drop 1, it was the third power, we're going to drop it to the second power, and our 2y to the third, we're going to go up 1 from 0 to the first power. Plus 3 times x squared, we dropped 1 more, it was squared, now it's going to be the first power, and our 2y to the third is going to go up 1 from 1 to the second power. Plus 1 times our x squared, we drop it again, it will be to the 0 power this time, and our 2y to the third goes up 1 and ends at our top power of 3. Okay, now let's simplify. So here we have 1 times x squared to the third, you multiply those exponents, that gives you x to the sixth. Here 2y to the 0 power is just 1. Then we have 3 times x squared squared, you multiply the exponents, that gives you x to the fourth, times 2y to the third to the first power is just 2y to the third, plus 3 times x squared to the first power is just x squared, 2y to the third squared, we need to square both parts, okay, so the 2 squared gives us a 4, and y to the third squared, you multiply the exponents, that gives you y to the sixth. And finally we have 1 times, anything to the 0 power is just 1, and then 2y to the third, again, remember to cube both parts to the, okay, 2 to the third is 8, and y to the third, you multiply your exponents, that gives you y to the ninth. Our last step here is to finish this out. 1 times x to the sixth is just x to the sixth. Here, multiply the numbers in front. 3 times 2 is 6, and then we add an x to the fourth and a y to the third. Here, 3 times 4 is 12, and then we had an x squared and a y to the sixth. And here, 1 times 8 is 8, and we had a y to the ninth. There is our full expansion. Okay. Notice it was plus in the middle, so all of our signs are positive rather than alternating.